This is a Zebra F701 ballpoint pen. In addition to stock, this pen can be modified to accept the Fisher Space Pen and Parker ink cartridges. But this video will show you how to make modifications to fit the gel ink cartridges as well. The all-metal inside and out version of the F701, which has the metal and not plastic button end. It's mainly constructed from plated brass and stainless steel tubing with a plastic core. The stock length modified pen. It's no longer a clicker pen, but a push and twist to lock. The longer gel ink cartridges will need to be cut shorter somewhat in order to fit, but in most cases the cut will not need to go through the ink portion. This modified pen is longer than stock by 8.5 millimeters, which allows most gel ink cartridges to fit without shortening. It's the desirable modification of the 701, although it does require obtaining the extra stainless steel tubing from either a Zebra F402 or another F701. This version is even longer and remains a clicker pen, but does require shortening of the gel ink cartridges somewhat. In order to have a full-length gel ink cartridge and still be a clicker pen, the body would be excessively long, which is undesirable. Okay, so let's take this pen apart and see how it's constructed. To keep from damaging the brass end of the pen and make it easier to remove, I made this tool from a piece of 1/8 inch thick aluminum scrap. It works quite well. Before disassembly, protect the stainless tubing with some tape. It can be easily scratched by the pocket clip. These pieces are brass. This spring keeps the button from rattling around. End piece is brass. This is the ink cartridge that comes with the all-metal inside and out version of the pen. Now the clicker mechanism gets pushed out the end. And here we separate the knurled grip, which is also brass, from the stainless steel body tube. It just pulls apart with some effort. And push out the plastic core. So let's now look at one of the issues of modifying the pen to take the much longer and wider gel ink cartridges. So this is the clicker mechanism. Normally the stock ink cartridge fits up into the barrel of the clicker tube. But the gel cartridge is too wide to fit. And by the way, I have found the Pentel inner gel to have the widest body of the gel refills, so I use it as a fit reference. But the Pentel Pilot G2 and even a China rollerball cartridge will fit into the brass end piece. So let's take a look at how much more cartridge length we can accommodate by eliminating the clicker mechanism. This much, that's significant. So here's another issue. The ball points fit, but the gels do not. So what's the solution? Well, here it is. This end cap, made from plated brass, is just the right diameter for the 701 and works great with many of the gel and ballpoint refills. It also gives the pen a more elegant look than the stock end cap, in my opinion. Now you might get the idea to cut off and use the plastic pen body as part of your modification. Don't do it. I did on 4 pens and all 4 broke their threads off and had to be rebuilt. Plastic is very brittle. You want to use a 5/16 inch diameter aluminum tube, which turns out to be the right size for threading to fit the new end cap. Let's take a look at this stock length pen and see what the threaded tube looks like as it's glued into the end of the knurled brass grip. So the question is how to thread the end of the aluminum tube. Well, the easiest way would be to machine the threads using a lathe, but not everyone has access to one. So I tried to come up with something that would do the job well enough with commonly available materials. The stainless steel clip made an effective cutter once it was shaped with a tooth profile. The wood dowel, which is made from a cut-down pencil, gets inserted and lightly glued into the end of the aluminum tube, and a hole is drilled in the dowel's center so it can be threaded onto the screw. Threads are cut as the tube is worked back and forth along the screw. The wood dowel is then punched out once the threads are cut. It does a pretty good job with some care. At least it cuts the threads deep enough so they can be finished off using the threaded cap as a die. Enlarge the end of the knurled grip so the tube will pass through. The end of the plastic tube gets cut off and replaced with the now threaded aluminum tube. Be careful of the dimensions here, as you want just enough threads protruding from the end of the knurled grip to fully engage the threads of the end cap, but still have it sitting flush when the pen is assembled. Both the aluminum tube and plastic core will need to be enlarged in diameter to accommodate the gel ink cartridges. I have found this is best done after the parts are glued together, as it's easier to clamp the body of the pen. Just protect it from damage. Turn the drill bit very slowly, preferably by hand. For the longer version of the pen, the core gets cut at a second location to accommodate the extra length of the stainless extension tube, gluing the core into the main stainless tube. This illustrates how the push and twist to lock is made. 2 flats are filed onto the button, taking care not to scratch the plating on the exposed part of the button. Two dimples are punched into the brass tube, creating raised areas inside the tube. The flats filed on the button should just fit between these raised areas. This is all that is really necessary to make the pen functional and works quite well, but is somewhat inconvenient as it requires aligning the button before it can be depressed. A further modification keeps the button in proper alignment for immediate pressing and limits its rotation to 90 degrees, a form of bolt action, if you will. I recommend this modification if you have the tools to do it, as it greatly enhances the pen experience. Take care with the alignment of the slot, as it needs to guide the flats on the button between the dimples and limit the rotation to 90 degrees. Also note that the pen should just guide the button in its travel and not take an actual load. Now this pen is put together differently from what I've shown you so far. It's the longer version of the pen and will accommodate the longer refills without cutting them down, but unlike the other pens which are glued together, this one is not. So let's take a look. On this pen, the aluminum tube is longer and grafted onto a length of the plastic core. This allows the pen to be disassembled, unlike the glued together ones. I've tried to illustrate what I did in this drawing. The plastic core gets cut 40 millimeters from the button end. About 3/8 of an inch of its end gets enlarged to fit the 5/16 aluminum tube, and the aluminum tube gets reduced in diameter to fit into the bore of the core. While best done on a lathe, the aluminum tube can be reduced by using a flat file. Some ink cartridge tips will require enlarging the opening of the tip hole. Here's one of my favorite refills, the Uniball UMR1. This refill is made for a non-retractable pen, but with some slight modifications and a shorter spring will work in the modified 701. Note that any cartridge that is too short for the pen will require a spacer, which can be made from an empty refill. Some views for length comparison. And a couple of pens I put together mainly from leftover zebra parts. Thanks for watching, and I hope you found this informative.